Hey everyone, welcome back to my system design series. Today we are going to dive into super important concept of system design that empowers everything you use online. That is a reliability. Think about it like how annoying it is when your website which you are working on right now or using it crashes or your favorite application stops working in between. And that is what reliability help us to solve. So let's start from the basics. Reliability using real life examples, and then gradually we will move towards the advanced topics. So reliability means your system works as expected without failing. So imagine if you are going to a school and a school bus picks you up every day. If it shows up 99% of the time, that means it is reliable. But if it misses picking you up once or twice, that means it is not that reliable. So in system design, reliability means how a system is dependable for their users and how often it stays up and running. Uptime and availability are key metrics used to measure reliability. Okay, so now why does reliability even matters and why it is so important? Okay, for example, think about like Instagram, Facebook, or any of the bank website. If these systems are not reliable, then the users won't be able to access them when needed, leading to frustration and even sometimes serious issues. So reliability directly impacts a company's reputation. So, for example, when you are using Facebook and Instagram, and if this system goes down, then the news spreads very fast. And because of that, users won't use it more often because there are a lot of chances that when you are using the application crashes, users won't like it, so they might stop using it day by day. So, one recent example was on 4th October 2021, Facebook and Instagram outage. Along with that, WhatsApp also went down for 6 hours. So this was a huge issue because this application is used by lots of users, even billions of users worldwide. And when these systems are unavailable, it impacts not only users but also business that rely on this platform for communication or advertising. This outage was very famous and it was published in all social medias. So, which highlights that how important reliability is for this kind of services. So, this incident shows the importance of reliability in system design. If outage happens more frequently, then users might, find some alternatives of this applications. So this is not good for business and it is not good for even this particular system. Okay, so we have talked so much about reliability. So now how we will measure the reliability? So for that, to measure reliability, we use SLA, SLO, and SLI. So SLA is service level agreement. SLO is service level objective. SLI is service level indicator. Okay, I have just mix this indicator. Okay, so let's talk about this in brief and then we will go into depth of it. So SLE is a agreement between the service provider and the customer. So this agreement states that how reliable service will be. So it is like this is service provider, for example any company They say that 99.9% of the time our service will be up. So it states that 99.9% will be uptime of cloud provider or service provider. Okay. So what is SLO? SLO is kind of internal goal of the company to meet SLA. So for example, if SLA is saying that 99.9% uptime, then SLO will target 100% uptime, or maybe 99.995% uptime. So the company will try to achieve this SLO, and even though if they are not able to achieve SLO, they will still be able to achieve SLA. That is what it is all about. Okay, so what do you mean by SLI? That is service level indicator. It is a kind of measurement like the exact percentage of uptime. I hope you are able to understand. Don't worry if you are not able to understand. We are going to understand it with the live examples. And I guarantee you, after watching this whole video, you will be clear about all these concepts. Okay, so I guess you might understood this thing, but let's talk about let's take in some small example for SLA. Suppose you are using cloud service provider, okay, and they promise you 99.9% uptime per month in their SLA, in their agreement. Okay, this means that out of total minutes in month, that is approximately 43,200, so service will be up for all this except 43 minutes, that is 0.01% downtime. So if they fail to meet this 99.9% uptime, they might offer you refund or some compensation to the customers, or compensation, and everything, and this all will be mentioned in SLA. So I hope you understood what do you mean by SLA. Okay, so let's understand SLO, service level objective. So an SLO is the internal target that the engineering and operation team sets to meet or exceed the SLA. So this is the goal. So this is the goal which is set in the company, and it is very strict compared to SLA, which allows some buffer to ensure reliability for the customer. For example, for example, if company's SLA states 99.9% uptime, the engineering team will set SLO to 99.9% uptime. The higher target gives them a little bit of leeway. So if something goes wrong and they only achieve 99.9% of the uptime in a month, they are still able to meet the SLA even though they fell short of their internal goal. So why SLO are so important? They guide engineers to maintain high standards and prevent the team to just aim for bare minimum SLA. With a slightly higher SLO, they are less likely to breach the SLA and face penalties or impact user experience. Okay, so I have written this thing in this note as well, and at the end of the video, I will share the link in the description and you can download it. So I really just want you to pay attention, and if you have any kind of doubts, then just put them into comment and I will take the doubts in the next video. Okay, the third is SLI, service level indicator. And SLI is a quantitative measurement of a specific aspect of a service performance. It is the actual data point that tell us how well we are doing against our SLO. Okay, for example, if we are measuring uptime as our SLI, we would track the percentage of the time when our service was available for a certain period, for example 30 days. At the end of the month, we will find an SLI showing 99.92% of the uptime for the month. So this is what SLI is all about. So how we are measuring SLIs? So we are measuring by latency, error rate, throughput. Okay, what is the one-liner definition of latency? Is time taken to respond to user request. Percentage of user requests that failed. Throughput is number of requests handled per second. Okay, so in two lines, what do you mean by SLA, SLO, and SLI? SLA are the promises to the users. Promises to user. SLO are the goals set by the engineers to meet or complete the SLA. Goals by engineers to meet SLA. And SLI are how they measure if they are meeting their goals. Alright, let's dive deep into how. How do we make systems reliable? So here are some of the practical examples. How to make system reliable. First is redundant. Redundancy means having backups or having duplicates. Imagine at your home you are using two service providers, and if one of the service provider is crashed, you can still be connected with the internet and use the second one. So in system design, redundancy means having multiple servers or data centers. For example, Google have the data centers in worldwide in multiple areas. So even if one data center crashes, the other can take over. Second is failover mechanism. Don't worry, I will complete this note and just pay attention here. Okay, so this is a system, and if system fails, then it will automatically move or use its backup. So a common example is the online payment system. So when the payment failure occurs, it automatically switches its server to its backup server. You might not even notice this, but this is what happening in the backend. Third is load balancing. We have discussed this in the last video as well, but let's talk about this in shorter example. Suppose this all are servers. So what load balancing will do if a user, multiple users are requesting? Okay, so this load balancer will equally distribute this request to avoid any server to be get overloaded, because if the server will get overloaded, it might stop working or it might even crash. Think of it as an example of grocery store. If you are standing in one of the line and the line gets very long, then the people will start moving to this another line, right? So this is an example of how the load is being balanced. Fourth is health check and monitoring. So systems continuously check its own health, catch the issues early. So this is like a car dashboard showing you the warning if there is an issue. Basic example is when your petrol is finished, or the petrol tank is kind of like in a way to get empty, you might get the red signal, right? Similarly, engineers set up this monitoring technique like CPU usage, memory, or response time. If anything unusual happens, then these alerts will notify engineers and they can work on the solution part. Okay, fifth is replication. So this means storing the copies of data into multiple server. So a practical example of this is Google Drive. When you save a document, it is saved in several places. So even if one storage fails, your document is safe and you can, use it from another storage. Okay. Sixth is data partitioning. So instead of storing all data into particular one place, we are splitting the data into different small chunks or parts. For example, an e-commerce website like Amazon might partition the data based on the region of customer. This makes each partition easily accessible and manageable. Okay, seventh is caching. Sometimes system stores frequently accessed data temporarily to make it available faster. So imagine a library, and when you are entering in the entrance, the most picked up books by the users are placed into the first shelf of the library. We are keeping it in this way for the quick access. So in system design, caching helps system to work faster and lighter on resources. Now what happens if the system have to handle multiple or millions of users altogether? So for high reliability, we are using the scaling techniques, and those are vertical scaling and horizontal scaling, which I have explained in detail in my previous video. So if you haven't watched that video, please go first watch that and then continue this. Okay, so these are some of the basics about reliability. Now let's move towards the advanced topic, that is distributed system and consistency models. Okay, so for systems with global users, companies rely on the distributed system, a network of connected servers working together. So first is CAP theorem, which I have already explained in the last video. CAP theorem. Here the CAP, C stands for consistency, A for availability, and P for partition tolerance. So this theorem guarantees that only 2 out of 3 can be applicable. So when a network issue happens, companies often have to choose between consistency availability or availability partition tolerance or consistency or partition tolerance. But mostly company chooses between consistency and availability. Second is eventual consistent. Some systems like social media uses eventual consistent. It means that data might take few seconds or some time to sync, but eventually will be same across all servers. So this is used for the things, suppose likes on YouTube videos or Instagram or Facebook. So even you can take an example, like you might have noticed that whenever you watch or start watching any YouTube video, you see, suppose there are 15 likes on that video, okay, but after some times, even like after 2 to 3 minutes, you see the same likes, but after ending or completing that video, the likes get increased and you might see 100 likes or 200 likes and lot of comments. So this is all about eventual consistency. So let's talk about distributed system in global applications. Distributed system in global applications. So let's understand the CAP theorem by a practical example of online shopping platform. CAP theorem for, let's take example of online shopping platform. So imagine we have the online shopping platform with warehouses and users in both US and Europe or Asia. So let's apply the CAP theorem on this. First, consistent. If someone from the US buys the last item in stock, so this information should immediately reflect into the Europe server as well as on Asia server, so that these users won't purchase those items which has been already purchased by the US person. So this way everyone sees the same data inventory. Second is availability. Even though the connection between US and Asia server goes down, then also website should be up and it allows users to buy products. This is called availability. Third is partition tolerance. If the connection between US server and Asia server breaks, so both servers should continue operating even though there is no network between them, and continue operating without crashing. This is all about partition tolerance. So let's talk about consistency versus availability. So if we prioritize consistency, then the users situated in the US might not be able to make the purchases until the connection is restored. And if we prioritize availability, the US and Europe have different inventory counts and might end up overselling of items. So most companies who have the users in distributed places, they prioritize availability and partition tolerance because it is better to keep the users interactive with the platform even if there is a slight delay in the consistent data. So let's talk about the eventual consistency with the practical example. Eventual consistency with practical example. So some systems use eventual consistency as a compromise. In eventual consistency, the data might not be instantly same across all servers, but over time they will all synced up and match the numbers. As I already explained and taken the example of social media like, so on Instagram, when you press the like button, this like is processed by the closest server located near to you. So this means your like won't be immediately shown to the server which is located far from your place, server 2, server 1, but within seconds it will update and display the same number of likes. So how it works? So when you have liked a post, the count might increase into your local server, and this server will eventually sync up in the background and updated like will be reflected everywhere. So this approach is very useful for the actions that don't need immediate consistency like likes or comments where a slight delay is acceptable. So summing it up, in a global system, distributed system help handle fast. So, summing it up, distributed system help to handle faster requests by spreading them across multiple servers. And second, cap theorem forces two choices. When there is network issue, prioritize two out of three, that is consistency, availability, and partition tolerance. Third is eventual consistency. It lets data sync gradually, which is useful for systems that don't need instant accuracy like social media interactions. So, by designing the system with these trade offs in mind, companies can balance reliability, speed, and user experience, especially when serving millions of people around the world. Okay, let's talk about something very important, like that is testing for reliability, and that is called chaos engineering. Testing for reliability, that is chaos engineering. This is a very unique approach. This is where engineers intentionally creates failure in the system to test the reliability. So Netflix have popularized this with their tool called Chaos Monkey, which randomly shuts down parts of infrastructure to see how well the system handles it. This way, the engineers can find the weaknesses and fix them before the real world users face it. So, how chaos engineering works? First, by setting up experiments. So engineers first set up some experiments with some specific goals. For example, if they want to test that if the website still remains accessible when few of the servers go offline, or if the data is still accessible when there is a delay in the network. So that is about setting up environment. Second is injecting failure. They can simulate various failing scenarios like shutting down few servers, shutting down requests, or cutting down some network connections. And this is how they can, inject the failure and how the system performance in that situation. They take a note of it and they can, work on improving or optimizing some of their functionalities. Third is observing results. So here the engineers monitor their system, like how they react in different kind of situations. Does it stay up or it get crashed? Are users still able to use their data or they are facing the delay in accessing the data? So this is all about observing result. Let's take an example. Suppose you are watching your favorite movie on Netflix and one of the server goes offline due to the chaos monkey. And if everything is working as it should be, you won't even notice that the server went down. The system would instantly redirect the streaming to another server without interrupting your movie. So it is very important. And why it is important? Why it is important? It prepares for the unexpected. Real world issues like hardware failures, sudden spikes in the traffic, or network outages can happen anytime. So, by intentionally creating this kind of situations, engineers can be prepared and even make the strategies in place to handle them. So, second is build confidence in reliability. Build confidence in system reliability. Okay, my handwriting is not that good, but we are able to understand, or maybe I should rewrite. When engineers have tested all kind of failures, they are confident the system can handle the issues without impacting the user. This builds the reliability and trust both for the engineers and for the end users. Third is fixing weaknesses before they are real problems. So, chaos engineering reveals the hidden weakness or bottlenecks. For example, a network failure might reveal that certain services don't redirect. For example, a network failure might reveal that certain services don't redirect automatically, and fixing this kind of issues early ensures that they don't turn into big problems during real user activity. So Netflix Chaos Monkey is a prime example of how companies create this kind of issues to prevent real disruptions. So because of this, the system becomes more reliable, which is essential for the large platforms where downtime and performance issue can impact lots of users and even impact their businesses. So this is all about reliability. We started with the basic concepts like SLA, SLO, SLI, then redundancy, and then we moved up to the advanced topic like cap theorem and chaos engineering. Reliability is what keeps the system run smoothly, so users like us don't have to worry about our favorite applications crashing. If you find this video helpful, then please make sure to like, subscribe and comment for more system design insights. You can leave any comments or suggestions which will help me to make more better videos for you, and even I would love to help you to understand this concept. So please make sure you subscribe to this channel and you can follow me on all other platforms, and see you in the next video.